All right, welcome to a new pad video. So today we have a 2011 Volkswagen Tiguan with a 2-liter turbo. Vehicle was actually towed in here with a intermittent or no start. Also, prior to the no start condition, it was a very rough running, low power condition, like no throttle response. So when we pull a vehicle diagnostic report, which is always one of the first steps that we take, you see here, this is our pre-scan report. This is the fault codes that were stored before we touched anything on the car. Under the engine control module, we have a few fault codes for ignition control circuit, cylinder 1, ignition control circuit, cylinder 2, random misfire cylinder 1 and 2 detected, intermittent as well. And we also have an intermittent fuel pump electronics defective fault code. So my point is, we're going to come back to that, but that's what was stored in the engine module. First thing I did is I actually checked fuel pressure. I got a fuel pressure gauge taped to the windshield. I connected the fuel pressure gauge. This is detecting low side fuel pressure, the pump that's in the tank up to the engine. We're detecting that fuel pressure. It was good, it was okay. So the car sat outside, it idled for a while, got up to operating temperature. I was going to go drive it. As soon as I put it in reverse, backed out of the parking spot, put it in drive, I'm in the parking lot, it stalls on me, it dies. It has a hard time starting back. So I put it back in park and I'm trying to get it started. Finally did, and was able to do so by giving it some actual throttle response, just enough to keep it up. So the symptoms were like a vacuum leak. That was what I was experiencing, like a large vacuum leak. So, got the car back into the shop here, and I want to show you what we found so far. So this is the part that came off the car. If you'll pan over here, you'll see where it has been removed. This typically sits right here on top of the valve cover, and there's a hose that connects, a vacuum hose that connects from the intake manifold to this oil separator or crankcase ventilation valve. It serves more than one purpose. So if you notice actually let's start here on the top side. I removed this cover because this part is very common failure item, and typically the failure is this diaphragm right here. I mean, it's right now you can see it's very discolored. It's very dry, brittle, and crunchy. I feel like if I pressed on it a little harder, it would just tear a hole in it. But that diaphragm should be very pliable, and it also should not be torn. So currently it is not torn, but I feel like it's on the verge of being torn. So anyway, this is a very common problem. You pull this little cap off, you look at that, you'll see that it's torn in most cases. So we see that that's not the issue with this one, so I need to go further. Well, flip it over on the bottom side, and there is supposed to be a little rubber diaphragm that goes right here. It's a one-way check valve for vacuum for the engine, or for crankcase ventilation. One-way check valve, it's gone. On a factory part, this right here is orange in color. That little rubber diaphragm is orange in color. So remember, this was the vacuum source to the intake manifold. So if we look down in there, you may be able to see, or if we can get a bore, you will need to get a bore scope. You can see those little fragments in there. That is tidbits of that rubber diaphragm. See the orange fragments in there? So I also noticed those same little fragments on the end of the intake right here. Right inside this hole, we can't get a photo of it, but right inside there where that hose connects, there's also those little rubber pieces. So we have a replacement part. So we've got one right here. You can see the new part, the rubber diaphragm is white in color, and that's what it should look like. You can see one little small hole right there in the center. You can see that piece is completely missing. See? There should be a little rubber diaphragm. So this right here, with that diaphragm gone, it's probably just oil saturated, deteriorated, come apart. Engine sucked it up through the vacuum pipe there, causing a massive internal vacuum. So that that's very symptomatic of what we've experienced, a massive vacuum leak. So we're going to put this new part, we're going to install it on the car, and we're going to start it up and see how that results, and we'll come back and show you the rest of it. Okay, so now we have that oil separator or crankcase vent valve replaced. The new part is installed on this car. We have cleared all the fault codes, and we've got the engine running now. So this vehicle, when it was just prior to this installation or repair, it was a no start. Towed in, no start. Now it starts up very quickly, very easily with a new crankcase vent valve installed. So we want to show you all the engines running. We have our scan tool connected, just a little bit of data. So our engine coolant temperature, you can see it's up there at 168. We can see we have no misfires on the engines, and this is live data. No misfires on cylinder 1, 3, 2, or 4. And we also have this self-adaptation value of 4%. That's a fuel trim. 4% is a fantastic number. Of course, the closer to 0 would be perfect, but 4% is certainly acceptable. Fuel pump, this is high pressure fuel pump, 40 bar. That's just shy of 600 PSI. So this is our high pressure fuel value. So we certainly do not have, and that is within specifications for Volkswagen. We do not have a low fuel pressure issue with the high pressure fuel pump. And if we look over here on our low pressure side, this is our low pressure fuel. This is our fuel supply from the tank to the engine. We're at about 65 to 70 PSI. I wrote down the specifications from Volkswagen. They're 4 to 7 bar is Volkswagen specification. That's a pretty wide range, but that's what they post. And that's anywhere from 58 to 102 PSI, 58 to 102. And we are certainly within specifications there with Volkswagen. So our fuel pressures on low side and high side are both good. I'm going to shut this engine off. We no longer have a check engine light. We no longer have any additional fault codes. I even took a fuel sample, and this is our fuel. We were just looking for any separation if we had maybe some bad fuel or gasoline. Not the case with this one. The fuel has good color, has no separation, has the proper odor that we would expect from a good quality gasoline. Also, we want to review these fault codes once again. We have ignition circuit cylinder 1, ignition circuit cylinder 2, misfires, and fuel pump electronics. So, my point is, in my experience, I've had these crankcase vent valves create misfires. I've had P0, 301, 302, 303, and 304. So I've seen these have misfire codes because of these vent valves, but I've yet to see one cause a stall and no start condition. This is my first one of these I have seen cause a no start condition. So for one to fail that bad. So my point is, it's not always logical to follow these fault codes, or don't replace parts based solely on fault codes that are pulled from the engine control module. Because as we can see, crankcase, ventilation, oil separator, ever how you want to call it, nothing relates that failure to either one of these fault codes. They're just not even corresponding. So what we've went by is our experience and what we've seen in the past and the symptoms the car had during this no start condition that led us to determine or at least look at that crankcase ventilation system. It's a common failure part or failure item on these cars. Typically it's this little diaphragm that we showed you earlier. There again, that's the first time I've seen one cause a no start condition, but we replaced it. I'm going to go drive it, but as of right now, it's perfect. It's running just fine. So thank you for watching another pad video. We hope this is helpful, and we hope to see you on the next one. Hit that subscribe button. All right, so I got an update for you on this 2011 Tiguan. So got the oil separator or crankcase ventilator back on the car. This car continues to prove how important it is not to throw parts at a car, and that your fault codes do not always correspond or correlate to the actual problem with the car, and also how vitally important it is to perform a post-repair road test. And one other thing would be how easily this scenario would have been for a shop to just throw parts at it and maybe possibly never fixed it. So I got the car back together. It started up perfect. It ran perfect. It seemed to drive just fine. I had no issues with it. The fuel trims were great. The fuel pressures were great. Had no problems. Everything seemed to be okay. I continued to drive. Probably a 20-minute road test. Well, during that road test, I'm varying my speeds. I'm changing my braking and steering, and I get the vehicle to fail on me again. So it hiccups a couple times. I pulled down a side street, put it up in park, and it finally just stalled. When I stopped, the engine stopped. It started back up. I put it in reverse for another 10 seconds, and it shut off again and would not start back. So it was very difficult to get it to start. I don't feel like it had anything to do with the temperature, but a few minutes passed, it started back up. I was able to get it back into the shop. Still no fault codes, no additional fault codes than what we showed you previously on our diagnostic report. No, not even a check engine light. So I raised the car up and I removed this little boost pressure pipe so I can gain access to the crankshaft position sensor, or Volkswagen calls it engine speed sensor. And I want to show you what I found. So if you come right in here, this is the engine speed sensor or crankshaft position sensor, whichever you prefer. So once I reached up here to remove the connector, I was going to connect my oscilloscope so I could see the waveform. Well, once I touched the connector, there should be a locking tab. Well, it's not locked at all. I mean, I can just pull it straight off. Well, not only did I notice the locking tab's broken and it just slides, but once I remove it, you can see the oil that is saturated inside the housing of that connector. Look here, look at that oil saturation. So what's happened is it's dry above it. Engine oil has protruded through the plastic housing of this speed sensor into the connection with the wiring harness. So engine oil has filled this void, and over time, I guess enough oil has made this connector that once was sitting very still because of friction resistance is now coated with oil, and the movement of the car, the starting, the stopping, the braking, the acceleration, the bumps that this car goes over on typical roads has over time loosened that connector and made it able to slide backwards to lose or cause an intermittent connection with that speed sensor. Now, when that speed sensor no longer provides a signal back to the engine control module, the engine control module doesn't know where cylinder 1 is at. This is how the engine control module determines cylinder designation for the firing order. So when the engine module doesn't know where cylinder number 1 is at, shuts it down. That's why it's stalling. So give me just a moment, I'm gonna get this sensor out and we'll look at it closer on the workbench. All right, so I have the speed sensor out. Let's take a look at it. This is the old one. You can tell how dirty and nasty it is. If you look down into the connector housing, look how oily. So it's very oil saturated. And I noticed when I turned it up earlier, actually a lot ran out, but you can see it dripping. But that's engine oil. So it has come through the plastic into that void there. So what's the fix for it? Well, we have a new sensor to start with. We're gonna go with a new speed sensor. But not only that, this locking tab right here is what is broken or missing on the one that's in the car. So that locking tab is crucial because when installed on the connector, that tab locks onto this one here, keeps it from sliding backwards. Well, that tab on the old connector is gone. So what I'm gonna do is this is a new connector from Volkswagen. Here's a new harness repair kit. This is the way they send them. So there's 2 terminals here for a 2-pin connector. I may or may not need to use this wiring piece, but I certainly need to replace this. So I will replace this for sure, replace this and solder it into the harness if necessary, but I may be able to slide the wires out of the old one and push them right back into this new one, to be determined. And install a new crank sensor, plug it in, take it down the road, perform another extended test drive. But this is certainly a lesson learned for me. I hope this is a lesson learned for any of the other guys out there watching, that how easily it could have been just to throw parts at it that corresponded to the fault codes, whether it be to answer a misfire codes, ignition coils, or spark plugs, or injectors, when it ended up being none of the above. So anyway, hope this video was helpful. We're going to forward it to our client. Feel free to like and subscribe to our channel. And thank you so much for watching another pad video.